There is a version of reality you have lived inside your entire life, solid, predictable, bound by causes that produce effects, by objects that exist in definite places, by a world that continues whether or not you are watching it. You wake up each morning and the floor is where you left it. The coffee cup does not flicker in and out of existence. The sun rises because it always has. This is the reality your nervous system was built to navigate. It is warm, it is reassuring, and by almost every measure that kept your ancestors alive on the open savanna, it is entirely sufficient. But there is another version of reality, one that sits beneath the one you can touch, one that does not follow the same rules, one that, if you look at it honestly with the full weight of the evidence that physics has accumulated over the past century, will not simply challenge your assumptions, it will dissolve them. And here's the part that I find most extraordinary. This deeper reality is not a speculation. It is not a philosopher's thought experiment or a mystic's dream. It has been tested, measured, confirmed to a precision that makes it the most accurate scientific theory in the history of human inquiry. Quantum mechanics. And the truly strange thing, the thing that keeps physicists quiet at dinner and awake past midnight, is not that it is bizarre. It is that it appears to be true. Most of us hold quantum mechanics at arm's length. We treat it like a curiosity, something relevant to physicists and engineers, something that lives inside particle accelerators and laboratory equipment, not inside the actual fabric of our daily existence. We tell ourselves a comfortable story. The quantum world is very small, and we are very large, and the two realms have nothing to do with each other. This intuition feels reasonable. It is also almost entirely wrong. The reason our instincts fail here is structural. Human perception evolved to operate within a narrow band of scale, things roughly the size of a fist to things roughly the size of a mountain, moving at speeds slower than a thrown stone. Within that band, classical physics works beautifully. But nature does not restrict itself to that band. Nature operates across 40 orders of magnitude in scale, from the Planck length to the observable universe, and our intuitions were never designed to follow it there. When we mistake our perceptual comfort zone for an accurate description of all of reality, we are committing the oldest error in the history of thinking. We are confusing the map for the territory. The first thing that happens when you genuinely trust quantum mechanics is the concept of the definite object begins to break apart. In classical physics, an electron has a location. It is somewhere. In quantum mechanics, before it is observed, it does not have a location. It has a probability distribution, a wave function spread across space, encoding all the places it could be, weighted by likelihood. This is not a statement about our ignorance. It is not that the electron is somewhere and we simply do not know where. The electron, in the most rigorous sense we possess, is genuinely delocalized. Werner Heisenberg's uncertainty principle, which I have always found to be one of the most elegant and devastating results in all of science, tells us that the more precisely you know a particle's position, the less you can know about its momentum, and vice versa. This is not a limitation of our instruments. It is a feature of reality itself. The universe, at its foundation, refuses to be pinned down. If that were merely a philosophical inconvenience, we might move on. But something far stranger follows. The act of measurement, the act of looking, appears to change what is there. The wave function collapses. All the possible states the particle could have occupied converge into the single state we observe. Niels Bohr spent decades wrestling with the implications of this. He concluded that it was meaningless to speak of the properties of a quantum system independent of the experimental arrangement used to observe it. Reality, in this framework, is not something that exists independently of observation. It is something that crystallizes through the act of engagement. This idea is not comfortable. It is not supposed to be. What happens at larger scales is even harder to absorb. In 1935, Erwin Schrödinger proposed his famous thought experiment: a cat sealed in a box with a quantum mechanism that would either release poison or not, depending on a random quantum event. According to the formalism of quantum mechanics, until the box is opened, the cat exists in a superposition of alive and dead. Schrödinger intended this as a reductio ad absurdum, a way of showing that the theory, taken literally, produces nonsense. But here's what the subsequent decades of physics have demonstrated. The nonsense is accurate. Superposition is real. Quantum interference, the mathematical fingerprint of particles genuinely occupying multiple states, has been measured in molecules, in biological systems, in systems of increasing scale. The world does not stop being quantum simply because it grows larger. The classical world we inhabit is not a separate realm. It is the quantum world seen from within. This brings us to the measurement problem, and to what I consider the deepest unresolved question in all of science. If quantum mechanics describes all physical systems, including measuring devices, including eyes, including brains, then what exactly collapses the wave function? Who is doing the observing? The Copenhagen interpretation, developed by Bohr and Heisenberg in the late 1920s, essentially tells us not to ask. The question of what happens before measurement is outside the scope of physics. Accept the formalism. Make your predictions. Stop inquiring further. This answer has always struck me as intellectually unsatisfying. It is, in a certain sense, a deliberate and institutionalized incuriosity. And I have always believed that science should be the opposite of that. If you are thinking now that perhaps quantum mechanics is simply incomplete, that some hidden variable theory will one day restore determinism and save classical intuition, you are in distinguished company. Albert Einstein believed exactly this. He called the idea that God plays dice with the universe absurd. He spent the last 30 years of his life searching for a deterministic foundation beneath the quantum formalism. But in 1964, John Bell derived a theorem in subsequent experiments, particularly those conducted by Alain Aspect in 1982, confirmed it beyond reasonable doubt that any hidden variable theory capable of reproducing the predictions of quantum mechanics must be non-local. It must allow for influences that propagate faster than light, or that somehow connect particles across space in ways that no classical mechanism can explain. Einstein's intuition, for perhaps the only time in his career, was on the wrong side of the evidence. If quantum mechanics cannot be trusted, it is the most spectacularly reliable failure in the history of science. Its predictions have been verified to 11 decimal places. The technology it underlies, transistors, lasers, MRI scanners, the device on which you are watching this, would not function if its equations were wrong. The universe is not merely described by quantum mechanics. The universe behaves according to quantum mechanics. And what quantum mechanics describes is a cosmos that is, at its core, probabilistic, non-local, an observer entangled in ways we do not yet fully understand. I find this not frightening, but clarifying. The universe is not obligated to be comprehensible to us. It is not arranged for our comfort or our intuition. Every time in the history of science that we have discovered a layer of reality deeper than the one we thought we knew, we have found something stranger, more intricate, and more magnificent than we had imagined. The quantum world is not an aberration. It is the foundation. It is the substrate on which all of the structure and beauty and complexity of the cosmos has been assembled. And the fact that we can reach down into that foundation, that fragile, curious, temporary beings on a pale blue dot, can construct instruments and theories that reveal reality at the level of individual quanta, seems to me among the most astonishing facts about the human situation. We are the universe becoming aware of itself. And we are doing so one carefully tested equation at a time. If you find yourself genuinely unsettled by what quantum mechanics implies, if it makes the world feel simultaneously less solid and more extraordinary, then you belong here. This channel exists for those who would rather be disturbed by a true thing than comforted by a false one. Subscribe if that is the kind of mind you carry with you. There is much more to explore.